Hello everyone, welcome. So this is the guided solution of the VCE NHT 2024 Exam 1, question 9D. So let us read the question. I extract the information from the question here and this is the graph. So it says here, let gx be the tangent to y equal to fx at the point 3 f of 3 using this derivative of negative x e to the negative x equal to fx, or otherwise determine the area of the region bounded by the lines y equal to 1, y equal to gx, and the graph of y equal to fx. Now, so this is from part A that we have fx equal to x minus 1 times e to the negative x. So this is from part A. So let's work through the solution because they are asking us to find the area of the bounded region, right? So let's look at how we can do it. So in general, the area of the bounded region, it will be the integration, will be the integration, sorry, it will be the, okay, it will be the, it will be the definite integral from the lower bound, that is a, from the lower bound, okay, from the integral lower bound, that is a, and the upper bound, that will be b, right, of, now this is important. So there's a bracket and inside the bracket it will be the upper curve, and then you need to minus the lower curve, lower curve dx. I hope it makes sense. So this is very important. We will use this formula in order to answer the question. So I will make it red color and it is important. Now, so let's analyze this one. So in our question, then the lower bound A, okay, the lower bound would be A and the upper bound would be 1. So the curve that we need to evaluate is the integration from 1, sorry, that is the integration from 1 to 3. And it would be the upper curve minus the lower curve. Yep. Okay, now let us analyze it one by one. First, first, let's figure out the integration of the upper curve. That would be from 1 towards 3, 1 towards 3 of the upper curve, right? Of the upper curve, the, okay, upper curve, and then dx, right? And that will, okay, that will, that will the upper curve is g of x, right? So I just replace all of this here with g of x. I hope it is understandable. G of x, and notice that because g of x is, okay, because g of x be the tangent to the curve, right? So then let us analyze this information together. Now, y equal to g of x be the tangent to the curve. Okay, now, first of all, y equal to g of x be the tangent to the curve. What does it mean? It means that, firstly, if g of x be the tangent to the curve at the point y at the point 3, f of 3, right? Then first of all, the gradient of the tangent, it will be the derivative. Does it make sense? The derivative, that is f dash of x evaluated at 3. I hope it is understandable. So this is the key point. The gradient of the tangent is empty f dash of 3. And then after that, right, because the tangent is a straight line, right? And because it is a straight line, then therefore the equation that it will have is y minus y1 will be equal to the gradient of the tangent x minus x of 1. Does it make sense? And now, okay, this is the key point. And in here, notice one thing, the point x1 and then y1, it will be a x1 and y1. Yeah. So this one will be a point on the tangent. A point on the tangent. So let us remember that. So that point in this case, I will pick it to be this point negative 3 and 3 here. In this case, it is that. Okay, now this is the key point. Okay, then so for now, you know how to calculate, you know how to figure out the equation of gx, and then the next step, you can just integrate this expression to figure out the definite integral of the upper curve. Then let's move on. Then for the next part, we will focus on the lower curve, right? Then this, the definite integral, but in this case would be the lower curve. So for the lower curve here, now what is the lower curve? The lower curve is actually our f of x, right? Then we need to be able to integrate. This is what we want. We want to find the we want to be able to integrate f of x dx with the boundary that is between 1 and 3. Does it make sense? Now, but because what is our f of x? Our f of x is this function here, right? This function here. So we need to be able to integrate it, right? We need to be able to integrate that function. Integrate that function from 1 towards 3. Integrate that. And because this is the product, right, between a linear and also a exponential. In fact, in method, we, okay, cannot be done in method. In specialist, you will have a method of integrating it. But right now, in within the scope of method, you would not be able to integrate it. Then how can we integrate this expression? We can do it by using what the question suggests us here. It is this information. That is when you, okay, that is when you differentiate negative x e to the negative x, you have fx. This information is very, very important to us. And why is that the case? Because now, because you integrate negative x e to the negative x and you have fx. So what does it mean? It means that when you antidiff fx. Yeah. When you antidiff f of x dx, what do you get? You should get this same expression. Does it make sense? Once again, because when you differentiate this expression, this function, right, you have f of x, meaning that when you antidiff f of x here, you should be able to get that same function. I hope it is understandable. And don't forget, you will have the plus c as well. Now, so the so for the upper curve, right? This is what we need to integrate, and this one will now actually become what will become. It will become the okay. It will become the the definite integral of fx evaluated between 1 and then 3, and that will just be this antiderivative here. This antiderivative here evaluated at x, that is -1, and then y would be 3. Does it make sense? So once again, by using this technique, you would be able to figure out what is the lower curve, right? The definite integral of the lower curve. And from above, we know how to figure out the definite integral of the upper curve. It is actually here. Then put them together, you will be able to figure out the bounded area between the two graphs. So also importantly, notice that because the tangent to a curve, the gradient for that tangent will always be the derivative of the curve evaluated at the point. Does it make sense? And also because the tangent is a straight line, so the it can be found using this equation. All right, everyone. I hope it makes sense. If you have further questions, please shoot me a message on the comment. Thank you so much for listening.